The problem is from GATE 2018 mathematics paper, question number 26. The problem given is, let gamma be the circle given by z equal to 4 times e to the power of I theta, where theta varies from 0 to 2 pi. Then it is asked the value of the integration over gamma e to the power of z divided by z square minus 2z dz equal to. The four options given are option A 2 pi I times e square minus 1, option B pi I times 1 minus e square, option C pi I times e square minus 1, option D 2 pi I times 1 minus e square. The NPTEL reference to solve this problem is Module 6, lecture number 5 of complex analysis. The title of this lecture is Residue Theorem and Residue Theorem and Applications by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. You can watch this lecture using this YouTube link. So now coming to the solution. So the gamma is given as the circle z equal to 4 times e to the power of I theta, where theta runs from 0 to 2 pi, and it is asked to calculate the circle integration over gamma of the function e to the power of z divided by z square minus 2z dz. So firstly, let's look at the circle. When we look at the circle, we can easily see it is, since mod z equal to modulus of 4 times e to the power of I theta, that is nothing but 4. So we can easily see the circle is nothing but circle of radius 4 in the complex plane. So this is gamma, let's assume approximately. So then the question here is the integration of this function over inside this circle. So for this we use residue theorem. So by residue theorem we have, which tells us that integration 1 divided by 2 pi I times integration over any curve gamma. Of course, in this problem it is given gamma as a circle. So f of z dz equal to summation residue of f of z at the points ai, where the summation runs over all ai, where ai's are nothing but are the singularities of f of z inside the curve gamma. So hence by this residue theorem we have, by residue theorem we have integration e to the power of z divided by z square minus 2z dz over the circle z mod z equal to 4. Instead of writing gamma, I'm just writing mod z equal to 4 since it is the circle given. So it is nothing but 2 pi I times residue of f of z at the point z equal to 0 plus residue of f of z at the point z equal to 2. Since z equal to 2, since z equal to 0 and z equal to 2 are the only singularities, and in fact these two are poles is of f of z inside gamma. So it is just enough to calculate the residue of the function f of z at these two singularities. z equal to 0 and z equal to 2. So then we can easily see the answer for this problem. So now the question here is, what are the residues of f of z at these 2 points? For that, I would like to introduce a formula to calculate the residue. That formula is given as, if f of z has a pole at z equal to z naught of order n. So whenever f of z, an analytic function, has a pole at a point z equal to z naught of order n, then the residue of f of z at that particular point z equal to z naught is given by this formula. Residue of f of z at z equal to z naught is 1 divided by n minus 1 factorial times, limit z tending to z naught, the nth derivative, n minus 1th derivative, of the function z minus z naught whole to the power of n times f of z. So this is the formula to calculate the residue of any function if whenever f of z has a pole. So now by using this formula we have, so the residue of f of z in our function. So okay, let me write z equal to 0. Since our function is e to the power of z divided by z square minus 2z, that is, and since here z equal to 0 is a simple pole, that is pole of order 1. So from this, from the previous formula, we have the value of n as 1 in case of z equal to 0. So for this we have the formula as limit z tending to 0 z minus 0 times e to the power of z divided by z square minus 2z. So in total this is given as limit z tending to 0 e to the power of z divided by z minus 2. So hence by applying this limit we get this as e to the power of 0 divided by minus 2, that is equal to minus 1 divided by 2. This is the residue of the function f of z, that is e to the power of z divided by z square minus 2z at the point z equal to 0. Whereas coming to the residue of another function, and residue of e to the power of z divided by z square minus 2z at the point z equal to 2. Even we can observe here that z equal to 2 is also is simple pole of this function e to the power of z divided by z square minus 2z, and hence we get this value as limit z tending to 2 z minus 2 times e to the power of z divided by z square minus 2z. So this is in total we get limit z tending to 2 e to the power of z divided by z. Hence we get this value as a square divided by 2. This is the residue of the function e to the power of z divided by z square minus 2z at the point z equal to 2. And hence since we have the residues, so we in total we can see the integration over the circle z mod z equal to 4 of the function e to the power of z divided by z square minus 2z dz is equal to 2 pi I times, as we have already seen from this, since we have calculated the residue of f of z at z equal to 0 and residue of f of z at z equal to 2. So I'm just substituting those two values. Those are nothing but minus half and e square divided by 2 minus 1 divided by 2 plus e square divided by 2. So in this is in total e square, okay, pi I times e square minus 1, and hence the correct option is as pi I times e square minus 1. So hence answer is option C.